Picture a scene. A hall in San Francisco, two people on stage. And these same two people, 8 years ago, put their names on one research paper. The paper that all of today's artificial intelligence stands on.
Attention is all you need. Literally, attention is all you need. The transformer came out of it, that mechanism underneath every large model.
And now these two people stand on opposite sides of the stage and argue. One says, "It works. Let's keep going." The other says, "We're stuck. We're sitting in a dead end, and we don't even see it."
Two co-authors of the same sentence 8 years later, on opposite sides. And you know what's best about it?
What?
That we genuinely don't know which one is right.
And that's what today is about. Hi, welcome to Season 3. For 2 seasons, we've been checking one forecast, whether the world is going the way AI 2027 said it would. Roughly, it is, only slower.
But every forecast has one assumption hidden underneath. That tomorrow will be like today, just more of it. More compute, more data, same direction.
And this season is about something else. About 8 things, each of which could make tomorrow not like today. Not about whether the curve comes true, about what could break it before it does.
And let's agree on one thing right away. None of these 8 things is certain. Every one is checkable. For each will tell you how you'll know it has started.
All right, so let's go back to that stage, because this argument isn't two scientists throwing tantrums. There's a concrete question behind it. Whether this transformer that everything stands on is the end of the road or just the middle of it.
And before we go deeper, ask me the question everyone has right now. Because I hear dead end, and I think, hold on.
Yeah, hold on. These models get better every year. They do more and more. So where's the dead end?
Because getting better costs more and more. This mechanism, attention, has a flaw. The longer the text you give it, the more violently the compute grows.
How violently?
With the square, double the length, the cost grows 4 times.
And 10 times longer text?
100 times more expensive.
Ah, so you add 1 page and you pay like it's 2, then like it's 4.
And that's the ceiling everyone keeps scraping against.
All right. On that stage, one sentence was said that I want to understand. Because the one defending the transformer is a Pole, Kaiser, co-author of the paper. And he set some condition.
A very concrete one. He said, roughly, I don't care that your idea is elegant. I care about the slope of the curve.
Meaning I have to show him that the more I put into my model, the faster it grows than the transformer, right?
Exactly. You can even be 50 times slower at the start. What matters is that you have a better slope.
So it's not about who's faster today. It's about who accelerates faster.
And it's an honest measure. It keeps us grounded. You're about to see how many contenders drop out against it.
So give me the first one.
The first is called SubQ, a company from Miami, Subquadratic. They came out of hiding in May and said, we solved the problem. Our model reads 12 million words at once, and attention doesn't grow with the square, only linearly.
12 million words. I need to picture that somehow. How much is that?
A dozen or so thick novels at once. In one context, without cutting them into pieces.
Okay, well, that sounds like a breakthrough. So you're probably about to tell me where the catch is.
There are a few catches, and that's exactly what's interesting, because this isn't a story of, behold, a breakthrough. It's a story of how to tell a breakthrough from a well-funded announcement.
So let's take the catches one by one.
First, they wrote a technical report, and in that report there's a sentence saying that the description of how their mechanism actually works is outside the scope of the report.
Wait, they wrote a technical report about an invention and left out the description of the invention?
Left it out.
That's a bit like someone announcing they built a perpetual motion machine and adding that how it works is a separate conversation.
You laugh, but that's exactly the shape of it.
Okay, second catch.
They admitted they didn't build the model from scratch. They took someone else's ready-made open model and modified this one element.
So it's not a new animal, it's an old animal with a transplant.
Probably a modified Chinese Quen model, though they didn't give the name. And the third catch is the prettiest.
So give me the prettiest one.
They boasted about an independent audit. That someone from outside checked it.
And this someone from outside turned out to be?
A firm their chief technology officer has worked with for 7 years. He admitted it himself when pressed.
So the independent auditor is a colleague of 7 years standing.
And the access was only through their own interface, not to the inside of the model.
Okay, but now I have to be fair, because we're kind of piling on them here. Maybe they really do have something? I don't want to be the guy who mocks every new thing.
And it's good that you say it because we owe them fairness. Their charge against the competition is concrete and checkable. They say, you pretend you solved long context, but your mechanism still quietly checks every pair of words.
So they accuse others of exactly the sin they'd be supposed to fix.
And they back it with numbers. It sounds like a real engineering argument, not marketing. So no, they're not con artists. The thing is, after 3.5 months, no one from outside has reproduced it. No one has access to the model. There isn't even a price list.
So what do we do with this? Believe it or not?
Neither. We remember one threshold.
Meaning?
On the day someone independent who doesn't take their money reproduces these results, it's a breakthrough. Until that day, it's an announcement. And that's the first marker of today's episode.
Let me tell you what bugs me about it. Even if it were real, it's one small player from Miami. How does one small player from Miami break the whole game?
And here's the surprise, because this heresy has already won, just quietly and not where people were looking.
How has it already won?
The third best model in the world is the Chinese Kimi K3, and it has this linear attention, this whole heresy, in most of its layers.
Hold on. So it's no longer a theory from Miami. It's sitting in a top 3 model in the world.
Sitting there, in 69 of its 93 layers.
Now I'm confused. You said dead end, and now you're saying the new approach has already driven into the top tier. So where's the problem?
The problem is that someone walked this same road and turned back. And to me, that's the most important thing in the whole episode.
Who turned back?
A company called MiniMax.
And what did they do?
They built a model on this linear attention, burned trillions of words of training on it, and then went back to the old, expensive quadratic one.
Wait, they had the new one and went back to the old?
Went back.
Why?
Because they did something almost no one in this industry does. They wrote up their own failure.
That's rare. Usually you hide things like that.
And they wrote plainly, efficient attention still has a long way to go before it truly beats full attention. And they showed where it broke.
And where did it break?
Exactly where the agents live today. In long multi-step reasoning, the model reads for you cheaply, but when it has to figure something out over many steps, it gets lost.
So you save on reading and pay on thinking.
Nicely put. And it's not a matter of tuning. They claim certain patterns get set very early in the model, and then you can't fix them anymore.
And that's what's interesting. Because when one takes this road into the top tier and another turns back on the same road, it means nobody actually knows.
Nobody knows. And listen, nobody has even honestly measured this Kimi K3 on really long text. That one number everyone needs to settle the argument simply doesn't exist.
All right, so we've got one heresy with an asterisk. But you said there are more.
The second one goes a completely different road. Diffusion models. Instead of writing word by word, left to right, they generate the whole answer at once and smooth it out.
Like a photo sharpening out of a blur.
Exactly.
And what does that give you?
Speed. Over 1,000 words a second. Several times faster than normal models.
Well, that's great. And again, I'm waiting for you to say where the catch is.
They measured what it actually costs. That speed doesn't come from saving. A diffusion model uses about 1,000 times more compute for the same task.
Wait, 1,000 times more? Then how is it faster?
Because it does everything at once, in parallel. Faster for you, waiting for the answer, but more expensive for the company paying the electricity bill.
So it's not a saving, it's a trade. You pay compute for time.
And that's why it isn't really a technical heresy. It's a bet on the price of electricity. These models win on the day compute becomes very cheap, not a day sooner.
You know what strikes me? That Google itself, which released such a model, wrote in the documentation, if you care about quality, take our regular one.
In black and white, it showed how much quality it loses and advised against its own product.
All right, now let's stop because we're reaching the thing that personally moved me most in all this research. The third heresy. Remember, in Season 1, we talked about something we called Neuralese.
I remember that bogeyman from the scenario. The moment a model stops thinking in our language and switches to its own internal one, unreadable to a human.
And we said that when that happens, we lose insight. We stop seeing what the model is thinking about.
But that was a forecast, something we feared for the future.
So now, pay attention, because a lab equivalent has appeared. Models that reason not in words, but inside, in hiding, and it works.
On a small scale, but it works surprisingly well. There's a model, 7 million parameters.
7 million? That's a tiny thing.
That's the size of one song on your drive.
And what can that one song do?
On a certain hard reasoning test, it beats Gemini 2.5 Pro.
Hold on. Something the size of a song beats one of the most expensive models in the world?
On that one specific task. And that's the first number, the one that impresses. Now the second, the one that cools you down.
Give me the cooling one.
It's one task. All these results are on models below 3 billion parameters, and no large lab has shipped it in a real product.
But the mechanism itself is real.
Real and measured. It's exactly that Neuralese from the scenario. Except for us, it was a dread from the future. And here it's a lab result, written up in a paper. And I'll tell you what puzzles me about it, because it's about to flip our intuition.
Go on, you're scaring me now.
We were afraid that if a model hides its thinking inside, it will lie. That hidden means sneaky. And it turns out the opposite. These hidden traces of reasoning were studied, and they were more consistent with the final answer than what the model writes out loud.
So what it shows on the outside lies more than what it thinks on the inside.
So it seems. Hidden doesn't necessarily mean sneaky. Sometimes it means more honest, just unreadable.
Now I genuinely don't know which side to stand on.
And good, because there's one more thing. Guess what OpenAI did when it noticed this?
I don't know. Were they happy? Scared?
They introduced a measure of how well a model can deliberately obscure its own reasoning on command.
Wait, why do they want a measure of hiding? Do they want the model to be able to?
The opposite. They want that value as low as possible. And they committed not to breed that ability in training.
Ah, so they posted a guard at exactly the door the scenario said would one day open.
Nicely put. And that's the second marker of the episode. Watch whether this hidden reasoning shows up in a really large model. As long as it sits in tiny ones, it's a curiosity. In a large model, it's a game changer.
All right, we have 3 technical heresies, but behind each stand concrete people, and some of them put really big money on it.
The biggest bet was placed by a man you know, Ilya Sutskever. For years, the chief scientist at OpenAI, one of the fathers of this whole revolution.
And he left, started his own thing, safe superintelligence, right?
Yes, and listen to this sequence because it's brilliant. Last November, Ilya announces, the age of scaling is over. Adding compute won't be enough anymore. We're going back to the age of research.
So he says plainly, just pumping electricity into the model no longer works.
That's what he says in November. And in July of this year, he signs a deal with Nvidia to increase his compute tenfold and says, we have research worth scaling.
Wait. First, the end of scaling. And 8 months later, time to scale?
8 months.
So he contradicts himself?
He'd say no. That his thesis is, first find a new idea, only then scale it. That everyone was scaling the old idea, and he was waiting for a new one.
Okay, that even holds together.
It does, but there's one thing that bugs me about it. You'll be surprised. How much do you think this company has managed to show in 26 months of existence?
Well, I don't know. They have $8 billion, so there's probably something already. Some demo, some model.
0. Not a single product, not a single paper, not a single demo.
At 8 billion? So what does that come to per person?
Over $320 million of valuation per employee. Without a single line of shown code.
That's pure faith. Faith in one man.
And he's not alone. There's a second one, David Silver. You don't know the name, but you know his work. He was behind AlphaGo.
Ah, that machine that beat the world champion at Go. That famous game.
That one. And he's the only person in the world who proved something really important. That a machine can discover knowledge that was in no human book.
How did he prove it?
His second machine, AlphaZero, learned chess and Go without a single human game. From scratch, playing against itself.
And what's he doing now?
He left Google, started a company on the thesis that models trained on human data will never reach true superintelligence. And he got the largest seed round in Europe's history, $1.1 billion.
For what? For slides?
In practice, for slides and for a name. He threw out a sentence that's the most megalomaniacal in this industry in a long time. That his law will explain intelligence the way Darwin explained life.
Well, that's either genius or someone who believed his own legend.
And here's the beauty. Because he has a record that justifies it, he really did once show that a machine goes beyond human knowledge. So when he says the current road is a dead end, he's not a random loudmouth.
And do all these defectors go the same way? Because Ilya and Silver sound similar.
No, and that's interesting. Take Murati. She was Chief Technology Officer at OpenAI, one of the most important people at the company. She also left. also started her own.
And promised the same as Ilya? No products, just pure research?
The complete opposite. She went the other way. She said, "We'll ship." And in July, she shipped the first model.
And how did it go?
Her own company wrote in the announcement that it's not the strongest model on the market, neither among the closed ones nor the open ones.
Wait, they wrote about themselves that they're not the best?
Themselves. And that's after 2 years and $2 billion.
That's brutally honest, but also a little sad.
It's the most honest measure of how hard it is to leave and build something truly different. Ilya promised to show nothing, and indeed showed nothing. Murati promised to ship, and shipped something she herself calls weaker. And Silver promised nothing and got a $5 billion valuation.
3 different answers to the same question.
And there's a fourth road, completely off to the side. LeCun, one of the fathers of deep learning, for years the chief AI scientist at Meta.
He left too?
2. And his thesis is the most radical. He says, large language models are a dead end, period. That real intelligence won't come from reading text, but from a world model, from something that understands physics, motion, cause and effect, the way an infant does.
A world model. Meaning what? That AI should learn like a child by watching, not by reading?
More or less. And he too got $1 billion to start. But listen to what his own chief executive said, because it's brilliant.
What did he say?
That in 6 months, every company in the world will call itself a world model to raise money.
So the head of a world model company himself warns that it's becoming a buzzword for pulling in cash.
Himself, in his own announcement, that's a level of self-irony you don't see in this industry.
All right, but now I want to put one thing honestly. Because here we're tallying up. Ilya bet, Silver bet. But has any of them proven it? Is there a result?
And this is the most honest sentence of the whole episode. No. As of today, there is not a single published result confirming any of these theses. There are valuations, there are names, there are billions, there's no proof.
So 4 people bet some $11 billion that the current paradigm is ending, and none has shown yet that they're right.
That's exactly how it has to be said. And there's a 5th player who behaves most interestingly of all. Care to guess who?
Since you're asking so slyly, it's probably someone I wouldn't expect.
Nvidia, the chip company. It's an investor in all 4 of these bets at once.
In all 4? In Ilya's? In Silver's? And in the other 2?
In all 4.
So it's not betting on who's right about the paradigm.
It's betting that each of them, no matter who wins the argument, will still need its chips. Whoever's right, Nvidia earns.
You know, that's a little sad. A grand battle over the future of machine thinking, and the only sure winner is the shovel seller.
Like every gold rush, the diggers come and go. The shovel shop stays.
All right, let's try to close this, because right now I have 6 different ideas in my head, and each pulls a different way.
And that's the right feeling, because the truth is, none of these heresies, taken alone, looks like a breakthrough today. Even the one that sounded best, diffusion, turned out on measurement to be a promissory note written against cheap electricity.
But they don't add up, do they? I have a feeling they multiply.
And that's the crux, because each works on a different layer. Diffusion gives speed, linear attention gives long context, hidden reasoning gives more thinking out of a smaller model.
So if someone put them together?
Each alone is a multiplier of 2, maybe 5. Together, it's the difference between an agent that can afford 1 attempt and an agent that can afford 100.
And that's the version of a breakthrough that needs no miracle.
It needs only that four things, which already work separately, start working together. But let's come back at the end to that Kaiser criterion, to the slope of the curve.
Because it's a ruler you can lay against every one of these heresies.
And as of today, none has shown a better slope than the transformer. That's why the transformer still wins. The audience in that San Francisco hall voted for its side too, by the way.
But the most honest sentence still isn't from the winner. It's from the one who turned back.
From MiniMax. They walked the heresy all the way, described exactly where it broke, and turned back. Someone who had every reason to defend their road and yet wrote, "Not yet."
So let's give people these markers to take away. How will they know something has shifted?
2. First, whether someone independent reproduces SubQ's results. Not them, not their friend, someone from outside.
And the second?
Whether this hidden reasoning, this lab Neuralese, shows up in a large model, above 3 billion parameters.
And if one of these thresholds falls?
Then we come back and say, remember the episode about the dead end? It just turned out it wasn't a dead end.
And for now?
For now, there are 8 people with billions, 2 co-authors of the transformer on opposite sides of a stage, and 1 shovel company that wins regardless of the outcome.
And that's the first of 8 things that could break this curve. A heresy in architecture. The model could jump onto a completely different road. Could.
But there's something strange in this whole story. If architecture can jump, then the company with the most compute in the world should find it easiest to do.
Exactly. Google. The most chips, the most money, the deepest bench of scientists.
And that same company, 3 times this year, promised 1 model and 3 times didn't ship it.
And that's the next episode. Because the reason the leader stalled has nothing to do with silicon.
See you then.